as I was doing the last video for the debate, as I was talking, I was like, hey, this doesn't make sense. I'm going to get destroyed. He's going to ask questions. I'm not going to have answers for him. And I don't even have answers to the questions I'm asking. So from whatever the last time I uploaded this, like 2-3 hours ago, I've done more research. I've watched more videos. I haven't read any books. That would probably have helped. But I thought I had like a month and a half to prepare for this. The producer, the guy running it, texted me like last week saying, hey, you got your flights and stuff? And I was like, absolutely. I was in bed, looked at my wife and said, hey, can I go to Vegas next week? She's like, yep. So I love my wife. This is fantastic. And we've gone through the debate. We're going to do it again. We're going to do it better. So this debate is on evolution. I am for the affirmative that it did happen. So the guest does agree with microevolution, as some people do. So I would ask him, hey, like, what is your definition of evolution? And I would simply go with small changes that happen, or just change in an animal, or whatever. Well, I'm getting excited. So traits inherited. And thus those changes accumulate, and then we have microevolution. And then from there, once again, I'd go back into my fox experiment, like I talked earlier, that they had 100 females, 30 males, and they were working towards an experiment to see if they could get them to be kinder. So after 4 generations, they got some small changes in tendencies, making them more kind. After 6, they saw some physical changes, the fur, the smell, stuff like that. But then after 10 generations, which is only about 10 to 15 years, they saw the snout starting to change. Then I would present this information to them and say, hey, would that be an example of a micro evolution? But 15 to 20 years to get physical changes is not too much. So we can agree on that, and now we push. You would like to see, Alex, the macro evolution would be a species changing. So if we were to get those foxes again and put them in 2 totally different environments, one that they're just doing whatever they want to do. Let's just say they're on an island that has a bunch of squirrels, so they got to get super fast, whatever it is. So their evolutionary tract, microevolution, is going to either make them faster, it's going to make them sneakier, it's going to make them this, it's going to make them that. I keep them over on this island, and they're catching fish or whatever it is. We give them 1,000 years, not just 30 years. There's going to be a lot of microevolutions. Cool. We give them 10,000 years. We're going to get even more evolution, but since they're not connected anymore, there's going to be there's going to be a change. There's a distinction. There's a new branch where they're not commingling. That's called population split. The difference builds over time. Stay on track. There's no longer normal exchanges of genes. That's where I'm getting at. So simple split diagram. I'll have one, and that's what I'm going to show them. Why do I have that in there? That's just showing how we can get macroevolution, a change in species. I needed to look this over. We're doing it now. So now we have foxes. We're going to go over dogs as well. Our branches joining. Oh, we're doing, the dogs. My goodness. So I have an image of dogs. Can I show? Do I have it ready? So these are foxes. Maybe I'm going to start with the dogs. Do I have dogs on tab 1? It's not dogs. Okay. So off those foxes, we have the Arctic fox, the kit fox. They are very similar to each other. And then you can get all the way to the hoary fox or Darwin's fox or the bush dog. As you can see, things are changing a little bit. But we're getting to some wolves over here. You can't see this. And then all the way on the bottom, there is black bear, there is giant panda, there is northern elephant seal, there is walrus. These are species that we have now. And the way they decide where their ancestors are is this is what I just learned, that the closer your DNA matches, the closer on the ancestral tree that you are on. The further that you match, the further away on the ancestral tree that you are. So you can determine whether you're 99%, like the Arctic fox is with this fox. It's like, hey, maybe it was 50 to 100,000 years ago that these guys kind of branched off. But that's how we figured out that the walrus and the bear and the fox are connected.